Hi, everyone. It's so intimidating to follow so many great talks. And I'm kind of just composing myself after those three amazing talks. But uh, but yes, hello. I am proud to admit that the first MP3 I ever downloaded was Ricky Martin's 1999 pop banger, "Livin' La Vida Loca," which I would then play dozens of times a day on an outstanding program called Winamp. And I downloaded this hit from the MP3 file sharing service Napster. And if you miss Napster, it introduced peer to peer networks to the world. It felt edgy and anti establishment. And despite what the music industry was saying at the time, it was so obviously like staring at a portal into the future. And recently, I've been trying to recreate my own Napster. It's been a really fun journey, and it's taken me into internet sockets, numerous servers, and eventually playing an MP3. And today I'm really excited to share that with you. And I'll start at the beginning via a pretty amazing reference from a reverse engineered Napster called OpenNap. So if we imagine we're in 1999 and we just booted up our Napster client on our Windows 98 machine, the application would call a redirector server, which was like a load balancer. And this would point you to a nearby server that hopefully wasn't overloaded. You'll then connect directly to that server. And we won't worry about the redirector anymore, but all of these connections, whether that is to the redirector, to your main Napster servers, or even to another client, which is known as a peer, these are all handled by sockets, which are provided to us by our operating systems. And you probably have a bunch of socket connections going right now, with at least one being used to watch this talk. Sockets basically power the whole of the internet. And if you have netstat installed, you can run that command now to take a peep at what you've got on your machine. Now, much of this incredible socket API is written in C, but almost all languages have an abstraction of it as part of their standard library. We'll be using Python today, but if you've never used Python, please don't worry. Hopefully, a lot of the syntax will be pretty familiar-ish if you've used another dynamic language like Ruby or JavaScript. So if we quickly dive into some code, we can load up our socket library. We can declare a variable to represent an internet socket. Now, there are other types, but the internet is what we're after today. And we'll also strictly be communicating with the TCP protocol. Again, there are other types, but this one creates a reliable two-way connection. Now with those, we can create a socket. And before we jump into Napster, we'll start with an example using HTTP by firing some binary data to the Bang Bang Con server. And we can even add a couple of headers to make it look especially legitimate. And we can get a really cool response back. And this turns out to be a nifty piece of HTML telling us to use HTTPS. Now look, this is all really cool. We're using the sockets API and TCP and all of this stuff, and we're not really worrying about it at all. The operating system is doing most of the work here. What we've done is taken some data and wrapped it with some HTTP protocol headers, and which in turn gets wrapped in some TCP headers by our socket library. And then some IP data gets added. Again, none of this is being done actively by us. And then some hardware data gets wrapped around a lot of it, like your Ethernet port or your Wi-Fi connection. This gets popped on at the end. And now when we whiz this packet of data down the magical internet pipes, and the Bang Bang Con server picks it up and does the same in reverse, stripping off headers until we're down to the original data that we sent. This layered network model means that we can focus on our application. And it also means I can give this talk without having to understand about 1,500 pages of network programming. And so when it comes to our Napster server, we're still using IP and sockets and TCP. All of those parts are the exact same. But while bangbangcon.com knew how to speak in HTTP, we need to make a server and a client that can speak in Napster. Now, actually setting up the socket infrastructure is very similar in both. For the client, we once again create a socket, we connect to the IP and port of a Napster server, we send a special Napster data packet, and then we read the response from the server, and we're done. Now, we'd need to code a little more to keep our connection alive, but this handles a single send and receive flow. And over on the server side, we start by booting it up with Python's socket server library, which is another abstraction on top of socket, and it will sit and wait for connections. We can set up a handler for when a client connects. We can grab our socket. We can receive data from the client. We can process it however we see fit. And then we can return a response. Now, there's a lot more we would need to do in a big production system with thousands of active users, but this is already quite a potent client-server connection as it is. And we can now start to think about what the actual data we're supposed to send between the client and the server would need to look like. All messages in Napster take the form of a packet that can be divided up into length, type, and data sections, with length and type being 2 bytes each. The value of length is the size of the data section in bytes. So our Napster client and server know how many bytes to read from the socket. Now, the ones and zeros of binary aren't something we really have to think about today, but I did do a talk last year about reading files from a PlayStation memory card, which goes into it in a lot more detail if you'd like to know more. What we do need to know is that we can encode these ones and zeros into human readable characters using a mapping called ASCII. We'll use this in the data portion of our Napster packets. We will also need to know that we write our length and type bytes, which are, remember, 2 bytes each, in hexadecimal format, which is like counting from 0 to 15, only we can do that with 1 digit, as we have 6 more digits added from A to F. It's a little bit sort of a mind-bendy thing. But the 0x part is just a way of making all the hexadecimaliness a bit more explicit. With this in hand, we can start to assemble our Napster messages. There's about 130 odd in Napster, but we'll only really be using a handful today. These 3, logging in, registering files, and searching for files, are the core ones for now. We use the length, type, and data sections of our message to create tiny little agreements between the client and server in how to communicate with one another. And the next step is gluing together our connection and our protocol and actually downloading an MP3. So Napster is centralized, which essentially means it takes on the role of a big MP3 librarian. And when we connect to our Napster server, we register a list of all of the MP3 files on our hard drive, which the server plops a record of into that index server. Details on the specific implementation are hazy, but I would imagine it was probably a big database. And so when a user runs a search for a certain file, the Napster server queries the index server to see if there are any matches. And if there are, it returns a big list of all the users it found. And inside this list will be the details needed to connect to the user who had the file that you wanted, allowing you to then initiate a direct transfer with them. And then finally, to get the file you were after. So actually implementing this is once again a very similar pattern to what we've already seen a couple of times now, an internet socket using TCP. We set up a little data class that would have the file name, IP of the server with the file, and the port. And we set up a little acknowledge function, which reads a single byte and returns a Boolean as to whether it was a string of 1, which we'll use in just a second. Then we set up a socket again. We connect to the peer who has the file we want to download. We acknowledge that the first byte we receive is that 1, which is like our little secret message. Then we ask for the file name that we want, and then we download it in nice little 1024 byte chunks. Meanwhile, the user we're trying to download the file from has got their own little TCP server running as well. And in their handler that fires when a user connects, they get a socket, they send a single byte of 1, they receive the file name from the user, and if they have the file, they send it in nice 1024 byte chunks. And again, we haven't really written too much code today. And while this certainly isn't production ready, these are the same fundamental blocks for a sort of genuine Napster server. And so I think we should run it. And this is the bit I'm super nervous about, because while I'm pretty sure I set my sound up and I don't want to spoil what's coming, I just hope I've set my sound up. So to see it in action, I deployed my server to AWS. I set up a client with a shared MP3 on another computer, and I can show you the client running from my computer. Ricky Martin is copyright, of course, so I didn't want to tempt fate here. Instead, I'm looking to download the distinctive and iconic MP3 that came with all Winamp installs, the powerful llama whipping intro. And after downloading it, I can add the file to Winamp and I can click play.
Winamp. It really whips the llama's ass.
And those 5 seconds are kind of my payoff for watching the rest of this talk. If you used Winamp back in the day, hearing that is probably a concentrated blast of nostalgia. If you did not, that was probably a very confusing 5 seconds. But with that, we created our own little version of Napster. Networking is such a fun and broad topic, and while we only really scratched the surface today, it's been so exciting for me to work on this and to have the opportunity to share it with you. Hopefully it's piqued your own interest a little bit into the sockets and protocols that underpin so much of our day-to-day lives. I have the code and some resources for more information for anyone who is interested on my GitHub, and please feel free to drop me a message on Twitter if you'd like to talk about this some more. And I would just very quickly like to end by saying a special thank you for all of the amazing organizers for putting together this wonderful conference, which always feels like such an inviting and comfortable space to be in. Thank you.